Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
Today we are going to talk about service mesh using Istio and Envoy. Right? So before we start, just wanted to inform you that this is going to be 1 hour session today. So the total time allocated for this topic is 4 hours. But because of some situation from my end, I have to be somewhere today early for work, and that's why I would be having a discussion only for 1 hour today. In the 1 hour, we will talk about what is service mesh, right? And then what is Istio. So what is service mesh and what is Istio and Envoy combination, right? And then we will see in detail, how Istio works, what is the architecture, and what are the various topologies for Istio setup or for the service mesh setup. So this we are going to try to cover in one day, and in the next sessions we will then see some hands-on demonstrations like installation of Istio, usage of Istio, and exploring the possibilities of what this service mesh can do. All right. So today we are going to talk about these topics in 1 hour.
On Thursday, are we going to, besides Istio, are we going to look at how Envoy is installed?
Oh yeah, so this Istio does not work without Envoy. So Envoy is a very core component of Istio. Although Envoy is a separate product, but Istio uses it in heavily. Right. So we will see how everything is done.
Okay.
Yeah. So let's start with discussion on service mesh. What is service mesh? So let's look at the life of an application, a microservice-based application without a service mesh, right? So we have a cluster. We can have multiple Kubernetes clusters, but let's start with a single cluster, and we have various microservices applications, right? So all these are microservices, and maybe this is a payment microservice. This is a user microservice. This is orders microservice, and many others, right? These microservices, because these are services in Kubernetes, they can talk to every other microservice. So payment microservice can talk to user, payment microservice can talk to maybe uh, cart microservice, the uh, the address microservice can talk to order microservice. All the microservices are free to talk to each other, right? And this communication is again plain text or based on HTTP, right? Now this works fine, but this becomes like a chaos, like yeah. So there are a lot of components talking to each other. It's very difficult to identify when a microservice is talking to other microservice, what is it doing, how much time it is taking to get a response from the target microservices, if the communication is failing, where is it failing. Also, the security is a challenge. right? So with the native Kubernetes-based microservices, you get these challenges. Some of these challenges are solved by service discovery, for example, console that we talked about last time. So console can have a registry of various microservices and their locations, and then console can ensure that the services are exposed correctly, and no, there is no need to hard code the service details in the application code, right? But that was just one problem. The problem was to know where our services are running. But here, when our microservices are running, there are other problems. The services are talking to each other in an unsecure manner, but we don't have any data on how this communication is working. Is it effective? Is it rejected many times? Is it being even successful? Right? So a lot of things are here. So how do we solve this problem? How do we increase our observability on this communication between microservices, and how do we ensure that the traffic actually uh, is successfully reaching the target microservices, and also the quality of service that the target microservice is providing is within our defined quality, right? So to keep an eye on everything here, we use service mesh. Service mesh is an extra layer, is an infrastructure layer, right, added to your deployment infrastructure. Okay, so although it's not I mean, when you install Istio and when you use it, it's not so easy to look at it as a separate infrastructure, but it actually is. Yeah. So so let me tell you how it works, and then maybe you will get some idea on what do I mean by this infrastructure layer. So as you can see here, the payments can talk to users, the payment can talk to addresses, the addresses can talk to orders. All these microservices talk to each other, right? But to gain observability on the traffic here, whatever traffic is floating around, or the data is floating around the cluster, to gain observability on here, what we do is we intercept this traffic. This traffic is intercepted. That means your application code, which is available in the pod or in the microservice, this is application code, right? Your container that is running in the pod. Well, if we do not use a service mesh, this pod or this container talks to this container in this pod. This container in this pod talks to this container in this pod, right? Directly, the communication is happening. But with service mesh, we introduce a proxy. Let me choose a different color here, right? We introduce a proxy. So each pod will now have a proxy. So it will be a multi-container pod here, and the pod will have a proxy pod. Okay, so this is becoming small. I will make a bigger diagram here. Let's say this is your payment pod, right? And this is your user pod, and this is your order pod. Okay, now each pod will have the application code. right? Where you define your business logic of your application. So this is a container containing your business logic, right? How to handle when a new order comes in, how to handle when a new payment comes in, how to handle when a user wants to explore his order details and all that stuff, right? So the containers talk to each other, right? But then you need to intercept, or we need to intercept this traffic to monitor the traffic, keep an eye on the traffic. And that is done by adding one more container here. So instead of the containers talking directly to each other like this, well, instead of this, the communication happens via the proxy. Okay, so if your payment application wants to talk to order application, well, the container will not talk directly. The communication will flow like this. Your application will initiate a request to talk to the order application, but it will go via proxy. And proxy will have complete configuration on how to or what data to generate out of this traffic request. Okay, there are a lot of things that proxy will do with this traffic request, and we will talk about them later. But then after this, the proxy will redirect the request to the proxy here. And this proxy as well will have all the configuration about what to get or what to extract uh, from this request that is coming in, and then send the request to this order pod or order container. Right. Similarly, when the order container sends a result back, again same thing happens. It goes via proxy, and all the information about this communication is captured. Okay, so this kind of means that you add a new infrastructure layer on top of your existing pods like this to monitor the data, monitor the network.
Is this proxy the same as like a couple of classes ago when we talked about proxies and reverse proxies? How is this proxy different or the same?
It's the same. I mean, it's the same. So, for example, although there is a pod initiating a request, the payment pod, which has the business logic, initiating a request to talk to the order application. Now, although it goes via the proxy pod, right? This order pod still recognizes that this request is coming from the payment application, although the request is being redirected here, right? So the proxy only exists to intercept the traffic, adds some more payload to the traffic, and then send it ahead. So it's just like a man in the middle, like any other proxy here.
Okay. Okay. So it intercepts the traffic, adds some more configuration, and then redirects it to the like order pod.
Yeah, to the original destination. Yes.
Okay. I mean, does it do this to like lower the overhead uh, I guess I mean, its functionality, is it for the security to like the traffic overhead? I mean, why use a? I mean, why use a why use a
Yep.
proxy?
I will come to that. I will come to that. So what is the benefit of adding this extra layer? Yeah, what's the benefit here? That's the question, right?
Yes.
Okay. Yep, I will come to that. But this is how. I'm just introducing you to how Istio is and what is service mesh actually, not Istio here. So this is a now what you do is underneath your pods, you are adding another layer of infrastructure which handles all the traffic part of your application. Okay, so you have a proxy which intercepts your communication and then gathers the data out of it and let the communication flow to the target pods or to the target containers. Okay, this is what service mesh is. But what does it do with the data that is extracted, the information that is extracted from the pods? Well, it forwards that data. mm, yeah, it forwards that data to another entity which is called as service mesh control plane. This will be also a set of pods and configurations inside the cluster, but the proxy, based on its configuration, it extracts some data from the traffic, and that data it sends to the control plane of the service mesh. Okay, so actually the entire infrastructure that I was mentioning is this. This is the infrastructure layer that runs on top of your cluster infrastructure to monitor your traffic, right? Now, the question is why? Why do we monitor this traffic? So we need to monitor this traffic to capture some information about the network, about this communication between pods, right? For example, let's say you have your application running fine, users are accessing the application, but sometimes when a user clicks on my orders button in the application, no data is generated. User is not able to see any data. Yeah, that means user is creating a request, but there is no data coming back to him. There is no data to display. So how will you debug that? Right? The first thing that you will have to do is to see how the request is flowing in your microservices component. So who initiated the request, then that microservice which got this request, where did it pass the request to, where did the subsequent microservice request for more data, and how is this communication flowing? Without an uh, uh, without a possibility to observe the traffic, you will never know, or you can only guess based on your architecture where the traffic is going. But the traffic is the traffic really going there? Also, if the traffic is going, what is the return you are getting? Is there any error in the return of that request? Right? You don't know all that. So for that, you need to intercept the traffic all the time. Also, you do not have any idea how much time is this request going forward and result coming back is taking. How much time does it take? Right? Does it result in 0.001 second? Is it happening in this? Or is it taking 0.1 second? Or is it taking 1 second? Right? Your performance of your cluster, of your application will be defined by this latency. But how do you get the information about how much is the latency of your application communication? Yeah, so that is defined by, again, intercepting the traffic and keeping an eye on when the request was sent and when the result was received. Right? So this is why you need to intercept the traffic. Make sense? Does it answer the question?
Okay, so you're Could you just repeat what you just said on like the last sentence on like on intercepting the traffic? So you have the infrastructure and the proxy that like intercepts the like the traffic, but with like was there something I missed with the time and because
Okay, let me explain it again. So when you have your microservices, right? So these are your microservices. They all can talk to each other freely, right? This payment microservices can talk to order microservice. It can also talk to user microservice. They all can talk to each other. This is an external user, let's say, and it accesses a web UI or web application. And internally, whenever the user clicks a button or types something, it expects a return of display of information on the web application. So the request may go to the payments microservice, and the payment microservice may internally need to get more information from the order microservice, and the order microservice may need more information from the user service. Then it will get back the result. This will get back the results, and finally the result will be displayed on the web application, and user will be happy, right? So this is how microservices work. Correct? Many components talking to each other. Now, as an application owner or the person who is responsible for this application, you need to ensure that this the network communication is healthy. What do you mean by healthy? Healthy means the response time is within limits. So the response time is low, right? From one microservice to another microservice, the response time is low, right? Also, you need to be able to debug any failures, right? Maybe a payment microservice has generated a request to a microservice which does not exist at all. Yeah, maybe the application development team did a huge screw up. They're trying to contact a microservice which does not exist, and that's resulting in the failure of application, and the customer is not happy because he does not see the detail that he is requesting, right? So you need to ensure the correctness of your network communication. Correct? You should also see or measure, for example, which service is used most, right? For example, some data that you want to generate. All right. You may also want to upgrade some services. This will be the second point. You want to upgrade services in canary deployment. Right? For example, some users will receive the latest version of the application, and some users will still see older version of application, something like that, which I will talk about later. So you want to do that as well. So you want to manage the traffic for that as well. How will you do this? How will you know if your response time from one microservice to another microservice is low? Unless you capture the exact time at which the service was initiated and the service reached the microservice. You have to timestamp these requests, right? So as soon as the payment microservice sends a request to the order, you capture this time. As soon as that request reaches the order microservice, you capture this time. As soon as the result is initiated here, you capture this time, and then you capture this time. So you know how much time it took your microservice to receive the request from this microservice to this microservice. So you know the time taken here, what is the latency, what is the reachability here. You also know how much time it took for the payment microservice from initiating the request to it receiving the result for the request. So you can also know how much is the response time from initiating a request to receiving a result by timestamping. Does it make sense, Anupam?
Yes.
Okay. Now, who will timestamp these network requests? Who will timestamp? Either you can put this in your application code. In your application code, you can, whenever you are requesting an external resource by authenticating to an external microservice or sending a request to on external microservice, in your application code you can add this logic that okay, microservice is going out, add a timestamp, or request is going out, add a timestamp, request is result is coming back, add a timestamp. But that's a huge overhead for the application development team to write all this logic and then work with this logic, right? So that's the overhead for the application team. Also, if there is an application already developed and in production, and then after deploying the application, which does not have this templating or say this timestamping code in the application code, if it does not have that a feature built in, then you cannot measure this response time because there is no code or no one timestamping these requests, right? So that is why this capturing of this data is actually not done from the application level. It is outsourced to another entity, which is the proxy, which we already talked about, right? We add a proxy to this application. For example, I will put it here. We add a proxy to all these applications. So all the networking request goes via the proxy. And in the proxy, we can add all our configurations on which network request should be timestamped and what should be monitored, what network we should keep eye on, and things like that. Okay, so instead of having all the logic of capturing the network, having all the logic in the application code, we have all the logic externally in service mesh. Does it bring some clarity?
Yeah. So you're saying that all the code, all the logic to capture all the like all the network and communication information is in the service mesh.
Yes. All the logic to capture important data from your network is in the service mesh.
Okay.
Any questions from anyone else? Because it's this topic is a bit abstract, right? Um, unless you see it happening, it's very difficult to understand, and it's very actually difficult to understand the problem statement that this is trying to solve. Okay, so if you have questions or if you have doubts, it completely makes sense. Okay, all right, so looks like it is clear now. This service mesh is implemented by many solutions, right, to certain degree by console as well, but Istio is by far the most complete implementation of service mesh. Okay, I'm going to clear this slide here. So how Istio works? Well, Istio has two components. Okay, maybe I'll just open Istio's documentation.
Thanks for watching. Want to study further? Join our training programs today.